In the silent reaches of deep space, where sunlight is faint and stars are countless, two small human-made objects drift farther from us than anything else we've ever built. These are Voyager 1 and Voyager 2, launched in 1977 on missions that were only expected to last a few years. But those few years turned into decades, and those missions turned into something far greater. What began as a tour of our solar system has become a voyage into the unknown, carrying with them not just instruments and cameras, but the hopes, questions, and dreams of an entire planet. Voyager 1, launched on September 5, 1977, and its twin, Voyager 2, which left Earth just days earlier on August 20, were part of a bold plan to explore the outer planets. The timing was crucial. A rare planetary alignment would allow the spacecraft to slingshot from one gas giant to the next using gravity assists, saving fuel and shortening the journey. This alignment occurs only once every 176 years, and NASA seized the opportunity. Their first targets were Jupiter and Saturn, the two gas giants that dominate our solar system beyond the asteroid belt. Voyager 1's flyby of Jupiter in 1979 provided the first detailed images of the planet's swirling storms and its enigmatic Great Red Spot. It also revealed volcanic activity on its moon Io, the first time active volcanoes had ever been observed beyond Earth. This was a monumental discovery. It told scientists that celestial bodies other than Earth could be geologically active, reshaping our understanding of planetary processes. When Voyager 1 continued toward Saturn in 1980, it transmitted stunning views of the planet's majestic rings and the mysterious, hazy atmosphere of its largest moon, Titan. While the probe could not land or even see beneath Titan's thick smog, it hinted at the possibility of organic chemistry and even the faint hope of life in environments beyond Earth. These revelations fueled curiosity and expanded the scope of what missions could look for beyond our home world. Meanwhile, Voyager 2 was taking a slightly longer path, visiting all four of the gas giants: Jupiter, Saturn, Uranus, and Neptune. Its encounter with Uranus in 1986 and Neptune in 1989 marked the first and only time a spacecraft has ever visited these distant ice giants. From Uranus, Voyager 2 uncovered the tilted magnetic field and the peculiar, icy moons orbiting it. At Neptune, it revealed the fastest winds in the solar system and a dark storm system that rivaled Jupiter's Great Red Spot. By the end of the 1980s, the Voyager probes had completed their primary mission. But NASA wasn't ready to say goodbye. Instead, the mission was renamed the Voyager Interstellar Mission. With their cameras shut down to preserve power, the spacecraft turned their attention to the edge of the solar system and beyond. Each probe carries with it a golden record, a message from Earth intended for any intelligent life that might one day find them. This record contains music from different cultures, greetings in 55 languages, sounds of nature, and images of Earth. It's a time capsule, a whisper from humanity, cast into the cosmic ocean with no guarantee of reply. The very idea is poetic, almost romantic, a gesture of cosmic outreach from a species just beginning to understand its place in the universe. Voyager 1 is now over 15 billion miles from Earth, and in 2012, it became the first human-made object to enter interstellar space. This does not mean it left the solar system entirely, as the Sun's gravitational influence extends much further. But Voyager 1 did cross the heliopause, the boundary where the solar wind is no longer strong enough to push back against the winds of interstellar space. Crossing the heliopause was a defining moment. Instruments aboard Voyager 1 detected a sharp drop in charged particles from the Sun and a simultaneous increase in cosmic rays from outside the solar system. It was a clear sign that the probe had entered a new region, an unknown territory where no human craft had ever ventured before. Then came the unexpected. In recent years, both Voyager spacecraft have started sending back data that confounds scientists. One such mystery came from Voyager 2 in 2023. Its magnetometer recorded fluctuations that couldn't be explained by solar activity or known interstellar phenomena. Some scientists described the data as resembling patterns seen in laboratory plasmas, something far too structured to be dismissed as noise. To make things even stranger, Communication with Voyager 2 briefly dropped out entirely after a misdirected command caused its antenna to tilt just 2 degrees off Earth. For weeks, engineers feared it was lost. Then, a miracle. NASA's Deep Space Antenna in Canberra, Australia, managed to pick up a faint heartbeat from the spacecraft. The team used a high-powered shout from Earth, a 19.5 billion kilometer whisper, and Voyager 2 responded. The antenna realigned. It was alive. The entire episode reminded us how fragile yet enduring these ancient machines are. The anomalies continue. Voyager 1's cosmic ray instrument began recording persistent fluctuations in particle density, something that shouldn't happen in the relatively empty space beyond the heliopause. Even more bizarre, there have been unexpected variations in the magnetic field strength and direction, as if the spacecraft were brushing against pockets of unknown energy or structure in the interstellar medium. One astrophysicist compared it to walking into a perfectly arranged room in a house you thought was abandoned. No dust, no decay, just stillness and the eerie sense that someone, or something, had been there moments before. Could these signals hint at a larger structure beyond our understanding? Are we seeing evidence of some cosmic architecture, or simply encountering new physics we have yet to comprehend? Despite being powered by nuclear batteries that are slowly losing strength, the Voyagers continue to function. Each year, NASA has to make painful decisions to shut off more instruments to conserve power. But even as their voices grow fainter, what they reveal grows more profound. They have detected plasma waves, magnetic disturbances, and cosmic rays that are reshaping how we view the boundary between solar and interstellar space. These aren't just interesting quirks, they are valuable clues to the nature of the cosmos. The information could inform future missions, space travel, and even theories about the structure of our galaxy. But let's not forget, these spacecraft are now over 20 light-hours away. A message sent to them today won't arrive until almost a full day later. Their signals, traveling at the speed of light, take nearly a day to return. This staggering distance gives us perspective. These probes are explorers in the truest sense, traveling blindly into the vast, cold unknown, long past the reach of our fastest rockets or our grandest ambitions. Eventually, sometime in the 2030s, their power supplies will be exhausted. The lights will go out. Their instruments will fall silent. But they will not stop. Voyager 1 and 2 will continue drifting through the galaxy for billions of years. Long after Earth has changed beyond recognition, perhaps even after humanity is gone, they will still be out there, silent emissaries of a species that once looked to the stars. And what of the golden records they carry? Perhaps one day, an advanced civilization will find them. Maybe not in 1,000 years, maybe not in 1,000,000. But if and when they do, they will find a greeting, a story, a picture of life on a small blue world that once orbited an ordinary star. And perhaps that moment, when someone or something finally picks up our message, will be the true beginning of the Voyager mission. Until then, they travel on, alone, but never forgotten. Every mile they gain is a reminder of human ingenuity and our innate desire to reach farther, to know more, to leave something of ourselves behind in the cosmos. In a universe that seems vast and cold, the Voyagers carry warmth, not just in their data, but in their purpose. They remind us that even the smallest of machines can carry the greatest of hopes. They are not just spacecraft. They are storytellers, time travelers, symbols of exploration. And their journey isn't just about where they're going, but what they mean to the species that sent them. At Discovery at 2.0, we believe that stories like this are not just about science or engineering, they're about wonder. About the human spirit. And the Voyagers, though silent and distant, still speak to us. They tell us to look up. To imagine. To discover.